Hey, what's up Blender users, I'm Jonathan, and in today's video I'll show you how to easily fill any object with fluids using Mantaflow. You can use this technique to, for example, create these satisfying animations. Oh, and by the way, if you enjoy my content, consider subscribing, because I upload a new video every Saturday. And with that said, let's get straight into the video. For this tutorial I'm choosing a relatively simple object, and this is going to be a torus. I'll quickly adjust the minor radius to 0.4, just so the space where the liquid is supposed to be can be a bit bigger. And now we'll rotate it by 90 degrees on the x-axis, just like this. We can also give it a subdivision surface modifier for some extra faces and shade it smooth. And now we want to fill this object with some kind of a liquid. Your first instinct might be to just add an element to it. For example, a sphere, scale it down, move it to right about here, and now just search for quick liquid, press enter, and we can already see there are some particles in our sphere. I quickly want to rescale our domain, so let's press Alt and S, scale it up and down on the y-axis, so we only simulate what is really necessary. And now let's also select the torus, choose fluid, effector and collision. Now to update our domain, let's change the resolution divisions to 64, and now we could press play. But you can see nothing is happening. If we would change the cache type to modular and bake again, you'll also see there's no fluid coming out of the sphere. Let's try something and move the sphere outside of the torus, for example to right here. If we bake again, you'll see that now there are actually flip particles coming out of the sphere, and they are also colliding with our torus. It now works because the sphere is not in a closed object like the torus. If we just quickly hide the domain and up here check our face orientation, we can see that all the faces face outwards, which they are supposed to do. If we enter the torus, you can see that everything is red. This means that these faces face inwards and mark that the torus is filled in the inside. If we would go ahead and flip all the normals, unhide our domain with Alt-H, and simulate again, you'll see that now the particles aren't colliding with the torus anymore. Okay, I mean that's great and all, but let's move the emitter back into the torus and actually work on our final simulation. For everything to work correctly, we'll need a solidify modifier and thicken the torus to the outside, just like this. We also need to move this modifier above the fluid one. If we now go ahead and bake again, you can see that our particles are colliding with the inside of our torus. And that's great, this is exactly what we want. We can also adjust the sampling substeps to, for example, 12 or even higher, if you have the patience to wait this long. Sampling substeps just allow the computer to simulate more simulation steps per frame. If we do this for every object, which in our cases are just the emitter and torus, the simulation will be more accurate. But of course you'll also have to wait long. Now let's change the flow behavior to inflow, so it doesn't just stop after the first frame, and bake again. And now you can see that our simulation is coming along nicely. The torus is filling up, and the fluid stays inside of the mesh. Now, because I don't want any particles, I'll just go ahead and enable mesh, and click on bake mesh. This process is relatively fast compared to the initial baking of the particles, so if you choose a relatively low optimus factor, you only have to wait a few seconds. And now our mesh is baked. But there's one problem we can see. If we hide the solidify modifier and look at our initial torus, you can see that the mesh exits our geometry. But luckily there's an easy fix for this. We can just go ahead and duplicate our torus, and now delete the solidify modifier and disable fluid physics for this object. And now move back to the world origin with Alt and G. We can now use this torus as a boolean for our fluid mesh. So let's go inside the modifier panel, select boolean, and our boolean torus. Right now it cuts away all the things we wanted to keep, so let's change the mode to intersect. And you can see that our fluid mesh now stays inside our initial object. Let's go ahead and hide the boolean mesh from the viewport and the renders, and let's start with the shading process. Now that everything is baked, we can either remove the solidify modifier or make it a lot thinner. For example, I'll set it to 0.05. If we would go ahead and remove the solidify modifier, we wouldn't be able to correctly see our simulation because of the refraction in the glass. So let's change the principled BSDF to a glass BSDF and turn down the roughness. And if we go ahead and enter rendered mode and disable scene world, we can perfectly see our fluid inside the tongs. But I don't want the fluid to be water, so let's delete both of these default nodes and add a principal BSDF and give it a nice color. You can of course just play around with all the different settings, for example maybe give it some subsurface scattering, but this is really up to you. I can now quickly show you what all of this would look like without the solidify modifier. And you can see that the glass refraction just destroys our nice look. So let's turn on the solidify modifier. And that's basically it. You can now just add in a simple ground plane and a camera. And you can also go ahead and light your scene until you get something that maybe looks like this. And yeah, that's it. This is how we can easily fill any object with fluids in Blender. I hope you learned something. I hope you found this tutorial helpful. And if you did, consider liking and subscribing, and we'll see you in the next